Hello, everyone. Welcome to your latest installment of Daily AI Brief, where we dissect the hottest trends and newest developments in the world of artificial intelligence. From revolutionary acquisitions to advancements in cryptography, we've got plenty to cover today. Buckle up as we dive into the fascinating realm of AI, technology, and their broader implications. OpenAI's recent acquisition of Astral, a renowned developer of highly efficient Python tools, signals a major shift in AI-powered coding practices. Known especially for their ultra-fast rough linter, Astral's tools offer significant performance enhancements across Python projects, something that OpenAI plans to integrate into its Codex AI coding system. Astral's primary contribution here is its suite of open-source Python tools, with Rough taking center stage. Rough is built using Rust, a language known for optimizing performance, particularly when applied to Python linting tasks. Rust's performance-oriented design provides Rough with its remarkable speed, marking it as a standout tool for developers striving to enhance workflow efficiency. These tools are designed to catch errors and enforce code quality standards rapidly, making them invaluable in fast-paced development environments. Rough's impact in the developer community is notable, driven by its execution efficacy. While exact metrics on user adoption remain undisclosed, its fast execution time impresses many. Developers often introduce intentional bugs simply to gauge its speed. Such deep trust in Rough's capabilities suggests a solid foundation for enhancing and expanding OpenAI's Codex. Codex, an AI system built to understand and generate natural language and code, stands to benefit greatly from Rough's integration. The focus is on creating a more seamless, end-to-end experience in the software development lifecycle, ultimately saving developers time and improving code quality. Despite the excitement around this acquisition, there are trade-offs and uncertainties involved. The timeline for integrating Astral's tools into the current OpenAI ecosystem remains undefined, and there are valid concerns about maintaining the open-source nature of Astral's offerings. Questions also loom on whether Astral's brand might lose its identity after becoming part of a larger corporate entity. For developers eager to get hands-on this week, exploring Astral's offerings is a good first step. By visiting Astral's official site, /astral.sh, UTM source, OpenAI, engineers can access detailed information and resources. Testing the Rough linter on Python projects provides a practical understanding of its capabilities and performance, offering insights into its potential integration with Codex. In essence, OpenAI's acquisition of Astral is a strategic maneuver, focusing on harnessing AI capabilities to enhance the development landscape. With potential improvements in speed and code integrity, developers can anticipate a more cohesive and productive programming environment. This acquisition not only highlights OpenAI's commitment to refining AI-driven tools, but also suggests future evolution in how AI can support developers worldwide. LlamaIndex has unveiled LiteParse, a TypeScript-native library designed to redefine spatial PDF parsing efficiencies in AI agent workflows. This new library significantly addresses the complexities developers face with intricate PDFs, propelling them towards refined AI implementations. LiteParse expands on the capabilities of previous tools like the LlamaParse API. It's specifically crafted for complex document workflows, allowing developers to integrate with existing systems swiftly. Utilizing a combination of text extraction and vision models, its hybrid architecture efficiently handles various document structures. This includes complex layouts, such as tables and charts, which are notoriously challenging in automated environments. One of the key strengths of LiteParse is its ability to transform these layouts into structured data formats easily. For instance, the library's automated chart extraction feature allows for conversion into Pandas data frames, enabling developers and analysts to manipulate and analyze data seamlessly. This capability not only improves accuracy, but also significantly accelerates processes traditionally bogged down by manual effort. Despite its promising features, LiteParse does have limitations. It currently focuses exclusively on PDF files, thereby missing out on broader applicability across diverse document types. Furthermore, its reliance on TypeScript could be a hurdle for developers entrenched in other programming languages. While it streamlines integration for TypeScript native environments, those using Python or Java might find it less accessible. Although no specific performance metrics were provided at launch, the potential benefits are underscored by past enhancements to LlamaParse, which included advancements like the Gemini 2.0 Flash integration. These innovations resulted in marked reductions in document processing costs and time. For developers eager to delve into LiteParse, a practical first step is reviewing the comprehensive documentation available from LlamaIndex. Instructions for setup are thoroughly outlined, enabling a quick start. Additionally, examining starter projects on GitHub can provide valuable insights into real-world applications and help determine its effectiveness within individual workflows. By engaging with these resources, developers can better assess how LiteParse might revolutionize their document processing pipelines. Looking to the future, LiteParse may set a new standard for AI-driven document processing. It aligns with industry trends that emphasize reducing manual data handling costs and could stimulate the development of even more specialized tools. However, its effectiveness in dealing with extremely complex document layouts and its integration with legacy systems remain areas to watch as the library is adopted more widely. With Google Colab's introduction of an open-source MCP server, AI agents can now engage more dynamically within the Colab ecosystem. This advancement aims to streamline code execution and workflows through a programmatic interface, boosting efficiency and innovation. The MCP server offers a standardized approach for querying public datasets, which significantly reduces the complexity previously involved in data interactions. By facilitating seamless integration with other Google services like Drive, Gmail, and Docs, it allows AI agents to utilize these tools programmatically, opening up new possibilities for automation and efficiency. Through its natural language processing (NLP) layers, the server can interpret user queries, ensuring that even those without deep technical expertise can interact with data intuitively. This capability supports a wide range of applications, from exploratory data analysis to generative reporting, traditionally cumbersome tasks for developers. From a technical perspective, the MCP server employs open-source components, which not only reduce development time, but also foster innovation. This open-source nature means that developers can customize implementations to suit specific needs, enhancing flexibility. It also integrates seamlessly with the Google Cloud platform, ensuring scalability as user demands grow. In terms of performance, while detailed metrics are not yet available, the server is engineered to leverage GPUs, which significantly enhances processing power and efficiency within the Colab environment. This allows for real-time data access with minimal computational overhead, making it particularly advantageous for enterprises looking to improve data-driven decision-making processes. However, as with any powerful tool, there are trade-offs and limitations to consider. One key concern is the potential security risks associated with allowing AI agents access to public datasets. Developers must ensure compliance with data privacy regulations, especially when handling sensitive information. Previous MCP implementations by other companies, such as Teradata and Cloudflare, have highlighted possible vulnerabilities that need addressing to ensure robust security. For developers eager to explore these capabilities, it's advisable to start by accessing the MCP server through Colab's interface using provided APIs. Further exploration can include integrations with Google Workspace services via the CLI. GitHub repositories showcase examples where AI agents interact with the MCP server, providing valuable insights into implementation strategies and best practices. In essence, Google Colab's MCP server paves the way for smarter, more efficient AI interactions with data, crucial for developers aiming to innovate with real-world data. By standardizing AI interactions and reducing the likelihood of hallucinations, it supports more reliable and insightful outputs, empowering enterprises and developers to focus on creativity and innovation. AI's increasing presence in software development is inadvertently contributing to systemic instability across internet services due to unreviewed AI-generated code. This has prompted urgent reevaluations of software practices globally. Recent analyses of 733 AI-generated code snippets reveal alarming vulnerabilities, with Python and JavaScript snippets showing security flaws in nearly 30% and 24% of instances, respectively. This reflects a broader trend where AI-generated code produces 1.7 times more issues than human-written code. On average, an AI-generated pull request contains 10.83 issues compared to 6.45 for manually written code. These numbers underscore the unintended risks presented by tools like GitHub Copilot, Code Whisperer, and Codium. The security weaknesses identified fall under 43 Common Weakness Enumeration (CWE) categories, 8 of which are noted in the 2023 CWE Top 25, including critical issues like CWE 330, insufficient entropy, and CWE 79, cross-site scripting. Such vulnerabilities can lead to significant operational outages and hefty security breaches, as observed in major corporations like Amazon. The dilemma facing developers is balancing the rapid output and automation benefits from AI tools against the increased security vulnerabilities they introduce. While 95% of organizations are leveraging AI in their coding processes, a mere 24% conduct thorough evaluations of the AI-generated code. This gap signifies a critical oversight in development practices that could facilitate potential security lapses. To mitigate these risks, developers should integrate comprehensive security evaluations for AI-generated code. Utilizing tools like Copilot Chat can assist in identifying and rectifying vulnerabilities, reportedly repairing up to 55.5% of identified security issues. Moreover, establishing rigorous code review frameworks can manage the potential for AI-related disruptions effectively. Such frameworks should include continuous feedback loops and adjustments in AI models to reduce the likelihood of learned vulnerabilities. The key takeaway is the pressing need for robust governance in AI code to ensure operations remain stable as reliance on automation increases. This includes rethinking traditional development and review methodologies to incorporate AI oversight. Companies must invest in training developers to enhance hybrid skills, merging traditional coding with AI review capabilities, ensuring they are equipped to handle evolving technological challenges. As the internet becomes further intertwined with AI-driven systems, the stakes for maintaining robust cybersecurity measures become ever higher. Regulatory frameworks will likely play a vital role in standardizing AI applications in software development, ensuring that innovation does not come at the cost of security and reliability. On February 11, 2026, Stability AI announced its full membership in the Tech Coalition, marking a significant step in its mission to protect children from online exploitation and abuse. This membership comes after a substantial commitment to the Pathways program through 2025, which focused on refining safety practices integral for child protection. The Tech Coalition is a distinguished global alliance that unites technology companies to address the widespread issue of online child exploitation. Stability AI's involvement in this coalition underscores its dedication to creating a safer digital world. By being part of this alliance, the company can exchange insights and collaborate on innovative safety technologies and strategies. A core element of Stability AI's approach is its Safety by Design framework. Established to preempt the spread of unlawful content, particularly child sexual abuse material. This framework is integral to their development and deployment processes, incorporating preventive measures directly into the architecture of AI systems. Such proactive design not only improves safety, but also reduces the company's liability, as seen in the favorable High Court ruling in November 2025, which determined that Stability AI was not liable for copyright infringement challenges, a nod to their robust safety protocols. In parallel, Stability AI has collaborated with reputable organizations such as the National Center for Missing and Exploited Children and participated in strategic dialogues with entities like Thorn and the Internet Watch Foundation. These collaborations significantly bolster its credibility and capacity to address complex safety issues. By participating in roundtable discussions and strategy formulation sessions, the company helps shape the future landscape of child protection in the digital realm. Despite these concerted efforts, some uncertainties remain. The actual effectiveness of Stability AI's safety initiatives is still unfolding, and the larger impact on online exploitation rates will require continuous evaluation and transparency. The company's success partly depends on the implementation and adoption of these safety standards, by the wider tech industry, which can be unpredictable. Following the company's progress can offer valuable insights into the emerging standards of digital safety. Interested parties are encouraged to review Stability AI's safety principles on their official site, keeping abreast of updates on collaborative projects. Monitoring outputs from organizations like Thorn and the Internet Watch Foundation can provide a deeper understanding of the ongoing efforts and their potential impact. The appointment of Prem Akkaraju as CEO in June 2024 symbolizes a shift in leadership, coinciding with increased focus on AI ethics and safety. This change in leadership is pivotal for directing the company's strategic ambitions and continuing to strengthen its reputation among clients and partners. Stability AI's involvement in the tech coalition not only exemplifies its commitment to ethical AI practices, but also sets a benchmark for other companies. It encourages wider adoption of safety-first principles, potentially leading to industry-wide benchmarks in AI child safety. Ultimately, these efforts might instigate a transformative shift in how digital ecosystems are regulated and safeguarded against exploitation, setting a standard for future technological advancements. In a revealing interview, Kevin Page, the Chief Information Security Officer at Conductor One, addresses the intricate challenges of identity security in the era of AI expansion within enterprises. The rapid proliferation of artificial intelligence agents, now autonomously operated by 95% of enterprises, has catalyzed a significant shift in the security landscape, where non-human identities are increasingly outnumbering human users in nearly 47% of organizations. Page champions a centralized identity management approach, drawing an analogy to a conductor who seamlessly coordinates various sections of an orchestra. This centralized strategy aims to streamline identity processes and fortify defenses against the 80% of companies that reported identity-related security breaches in the previous year. The orchestration models and API integrations he suggests are instrumental in unifying disparate identity systems, allowing for comprehensive, streamlined identity verification. The crux of Page's argument lies in embracing AI-native identity security platforms, which are becoming indispensable as the expansion of AI introduces new identity-related vulnerabilities. For instance, with an expected 89% of organizations planning to integrate AI agents within their security departments over the next 2 years, the pressure to advance identity governance frameworks is mounting. Practical steps for organizations include reviewing the Conductor One's blog on identity management strategies, which provides insights into the latest tools and methods for effective identity governance. Businesses should also consider examining resources such as the 2025 Future of Identity Security Report to obtain deeper insights and forecasts in this domain. API integration is another critical component in bolstering identity security. By implementing robust APIs, organizations can achieve streamlined identity verification and risk management. This integration aids in reducing the complexity associated with managing both human and non-human identities, ensuring protective measures are both proactive and adaptive in nature. However, Page also points out trade-offs and limitations facing this evolving landscape. The rapid growth of non-human identities poses managing challenges, while the introduction of AI agents can inadvertently bring unforeseen security vulnerabilities. Companies must carefully balance automation and human oversight to prevent undermining security frameworks. The implications of these strategies are profound. A shift towards centralized identity management and AI-enhanced platforms could significantly bolster organizational resilience against breaches. Developers are encouraged to incorporate best practices in identity management early in their development cycles, fostering a culture of security-first thinking. Ultimately, as identity-related threats continue to evolve, the collaboration between security and development teams will be paramount. Such partnerships will ensure that identity management practices remain robust and capable of defending against the complex threats posed by AI's growing integration into enterprise operations. The demand for AI-native solutions is expected to spur innovations, compelling even traditional identity access management providers to evolve or risk obsolescence. In today's fast-evolving digital landscape, enterprises are encountering a less obvious but potentially devastating risk: exposure of operational secrets through AI tools. With approximately 39.7% of AI interactions involving sensitive data, organizations face a heightened threat of data leaks if proper security measures are not implemented. AI usage within companies often goes unnoticed due to the rise of shadow AI, where employees utilize unauthorized AI tools. These practices can bypass established security protocols, thereby creating substantial governance gaps and exposing enterprises to both legal and cybersecurity threats. Traditional security measures such as firewalls and static passwords often fall short in addressing these AI-specific challenges, which underscores the urgency for new protective strategies. Innovation in AI governance has led to the development of authenticated workflows, a concept introduced by researchers Rajagopalan and Rao in 2026. Acting as a trust layer, authenticated workflows are designed to ensure the integrity of AI interactions by securing four key boundaries: prompts, tools, data, and context. This security is largely achieved through advanced cryptographic methods, ensuring that any data interactions within AI systems are constrained and verified, significantly lowering the risk of unauthorized access. The effectiveness of these workflows was rigorously tested across 9 AI frameworks, yielding 0 false positives in 174 different cases, highlighting their robustness. Moreover, the integration of the MAPL, machine learning application policy language, facilitates dynamic management of agentic constraints, thereby allowing flexibility while maintaining stringent control over sensitive data. Implementing these workflows introduces several challenges. Balancing the autonomy desired in AI applications with necessary security measures requires careful deliberation. Enterprises must adapt such frameworks to fit their unique contexts, ensuring that scalability across various AI models does not compromise security. To effectively mitigate these risks, organizations should begin by conducting thorough audits of existing AI tool usage, identifying and closing any governance gaps. Employing authenticated workflows as part of this audit can enhance data handling by providing real-time auditing and monitoring capabilities, thus ensuring compliance with internal and external security standards. Going forward, enterprises must not only integrate these advanced security measures, but also educate staff on the legitimate use of AI tools, emphasizing the risks associated with unauthorized usage. Regular training programs can help maintain awareness and compliance, ultimately transforming an organization's risk management strategy against AI-generated threats. The path to mitigating secrets exposure through AI tools is one that necessitates immediate attention and action. By understanding and implementing new frameworks, enterprises can safeguard their data integrity and build a more resilient security posture in the age of AI. The integration of AI agents into enterprise workflows has rapidly increased, emphasizing the critical need for robust standards within agent control planes. As companies like Microsoft, Salesforce, and Oracle lead the charge in developing these frameworks, they aim to mitigate the risk of agent sprawl, duplicated efforts, and operational inefficiencies. The development of standardized governance frameworks is essential to manage the potential complexity and inconsistencies affecting AI deployments. A key component of this effort is the Unified Agent Lifecycle Management (UALM) framework, which divides the control plane into 5 distinct layers: identity registry, orchestration, PHI-bounded context, policy enforcement, and lifecycle management. These layers are designed to foster clear accountability and smooth operation of AI agents. For instance, identity management treats digital agents as enterprise employees, requiring identity and access management (IAM) systems to define and monitor roles and permissions effectively. With projections indicating over 1 billion enterprise agents by 2028, according to IDC, the scale necessitates precise orchestration methods. These methods must seamlessly integrate myriad agent types into business processes, ensuring efficient runtime operations. Essential to operational integrity, policy enforcement mechanisms include strategic components such as kill switch triggers to maintain compliance with evolving regulatory landscapes. Lifecycle management also plays a critical role by administrating credential revocation and audit logging, which are crucial for upholding a transparent accountability structure. Adopting these frameworks can significantly reduce compliance risks and operational inefficiencies. Nevertheless, scalability is a concern as centralized control planes face potential challenges due to the rapid expansion of agent populations. Organizations must carefully assess their current integration processes and explore the centralization of governance through ULM frameworks to enhance oversight. Traditional ad hoc agent deployments may contribute to compliance inconsistencies and security vulnerabilities. By contrast, mature models like those in agent control planes offer businesses a competitive advantage, fostering innovation while setting industry benchmarks for evaluating agent performance. Developing stringent control mechanisms not only reduces operational risks, but also strengthens trust in AI technologies among stakeholders and end users. Ultimately, constructing standardized agent control planes represents a promising path to enhance AI system reliability. As these models evolve, they will likely drive significant advancements in compliance and control mechanisms, signaling a new era for digital workforce governance. By embracing such structured approaches, enterprises can streamline operations, align agent objectives with business goals, and remain agile in a technologically dynamic landscape. Celebrating the revolutionary achievements of quantum cryptography pioneers Gilles Brassard and Charles H. Bennett, the recent ACM Turing Award highlights their seminal development of the BB84 protocol. Originating in 1984, this protocol has become a cornerstone for secure quantum communications, underscoring its increasing importance as quantum computing capabilities advance. The BB84 protocol innovatively utilizes quantum mechanics to establish secure communication channels. By encoding information onto quantum states such as photons, it allows for the detection of eavesdropping attempts, a critical feature to ensure secure transmission. This was a groundbreaking leap from classical encryption methods, providing a level of security previously considered theoretically unbreakable due to the principles of quantum mechanics. Quantum key distribution, QKD, builds upon these principles, enabling parties to generate a shared, secret key known only to them, which can be used to encrypt and decrypt messages. The introduction of this technology sparked a shift in cryptographic thinking and laid the groundwork for the burgeoning field of quantum information science. Despite its promise, the BB84 protocol and its implementations face significant challenges. The delicate nature of quantum states often results in high error rates, which can compromise the integrity of communication channels. Additionally, maintaining quantum coherence over distances remains a formidable barrier, limiting practical adoption. Current QKD systems require advanced and costly hardware, which restricts broader application and raises scalability issues. To gain deeper insights, one might explore the original 1984 BB84 paper, which provides a comprehensive explanation of its mechanisms. Additionally, examining how commercial encryption products are integrating QKD can reveal significant advances in protecting digital communications against emerging quantum threats. As research progresses, the potential of quantum cryptography to revolutionize secure communication is immense. Its theoretical security offers a roadmap for future-proofing communication systems against the impending challenges posed by rapid advancements in quantum computing. The ACM Turing Award recognition amplifies the importance of continued innovation and development in this critical field of cybersecurity, marking an essential pivot in efforts to secure our digital future. In an era where AI models demand substantial computational resources, innovative methodologies for optimizing training costs without compromising performance are essential. The increasing complexity of models necessitates not just technological advancements, but also eco-efficient strategies. Dynamic data management during AI training cycles emerges as a powerful technique to streamline the process, offering a significant reduction in computational overhead while maintaining accuracy. The essence of dynamic data reduction lies in its ability to intelligently manage inputs during model training. By selectively adjusting and reducing the volume of data fed into the system, this strategy can cut energy consumption by up to 50%, as highlighted by recent studies. This reduction isn't merely about lessening the electricity bill. It's crucial for reducing AI's carbon emissions, a pressing concern as AI usage intensifies globally. For context, training large models like GPT-3 consumed approximately 1,287 megawatt hours of electricity, leading to the emission of 552 tons of CO2. Such figures underline the necessity for efficient training methodologies. Moreover, as AI systems become more pervasive, data centers are expected to consume around 1,050 TIA hours by 2026, potentially ranking as the fifth largest global electricity consumers. Against this backdrop, integrating techniques like multi-agent reinforcement learning for workload optimization becomes imperative. These algorithms are designed to allocate resources efficiently, ensuring that power-hungry AI systems run more sustainably. Dynamic data reduction isn't without its challenges. The long-term effectiveness and scalability of these techniques across various applications are currently under scrutiny. While initial results are promising, comprehensive evaluations of performance reliability and data integrity in large-scale environments are essential. Researchers need to ensure that these methods do not inadvertently compromise the rigor of AI training or encourage shortcuts that might lead to degraded model effectiveness. Practical implementation calls for pairing dynamic data strategies with energy-efficient hardware solutions. This dual approach can not only lower operational costs for developers, but also set new standards for sustainable AI development. By integrating workload optimization algorithms into data centers, business operations can become more responsive to energy demands and potentially decrease carbon footprints significantly. As concerns about AI's environmental impact grow, these innovations offer a pathway to reconcile technological advancements with sustainability imperatives. While debates about the precise role AI plays in global carbon emissions continue, these approaches provide actionable insights to mitigate negative environmental effects and align AI development with eco-friendly priorities. That's a wrap for today's episode of Daily AI Brief. We've explored how AI is evolving in coding, document processing, and quantum cryptography, providing glimpses into a future where technology and innovation meet sustainability and security. Keep tuning in as we continue to unravel the layers of AI advancement and impact. Until next time.